I'm Anil Kumar. Welcome to my series on problems relating to circles and chord segments. We'll have a couple of multiple choice questions in this video to practice and understand the concepts. The first one here is, two chords AB and CD intersect at P such that AP equals to 4, PB equals to 6 centimeters and DP equals to 8 centimeters. Find the value of X. So these are the two chords which intersect at P. AP is 4 centimeters, so all units are in centimeters. P to B is 6 centimeters, P to D is 8 centimeters. You need to find the value of X. Now here it is an application of segments of chords theorem, right? So this is segments of chord theorem. So according to this theorem, whenever you have two chords intersecting in any circle, in that case the product of the chord segments is same, right? So basically the product of chord segments is same. So that is the theorem. So based on this theorem, we can straight away find the value of X. So we have 4 times 6, that is to say, we can say AP times PB should be equal to CP times PD. Substituting the values, we get 4 times 6 equals to CP is X plus 1 times 8. So X plus 1 is equals to 4 times 6 divided by 8, which gives you, that goes 2 times and that goes 3 times, right? So what we have here is 3 equals to X plus 1, and that tells you that X is equal to 3 minus 1, which is 2, right? So the answer B is the right option. Correct? So it can easily be done. 6 times 4 is 24. So we are actually looking for product of 24, right? So 6 times 4 is 24. 8 times 3 is 24, correct? So X plus 1 should be equal to 3. X is equal to 2. So that fast we can do it, right? It's an easy question. Here is the next question. Tangent and secant intersects in the exterior of a circle at A as shown in the figure below. Find the value of X. We are given 4 choices. Now here the length of the tangent is 6 units. A to C is X and C to D is 16. You can pause the video, answer the question, and then look into my suggestions. Now here you have to apply the relation between the secant segments and the tangent, right? So basically the relation is that AB square should be equal to AC times AD, right? So that is the relation. So these lengths, this is product of AC and CD. Now AB square is given to us as 6, so 6 square is equal to AC is X times AD, which is 16 plus X. So we get here 36 equals to X times 16 plus X, right? Now you could factor and find the solution, but the easier method is that, you can find the factors of 36. 36 could be written as 2 times 18, right? So 2 times 18 is 36. If you substitute 2 for X, right, you do get 2 times 18, right? So therefore, we can find that the value of X is 2, right? Or you could continue with the expansion of this and solve the quadratic formula. You could do that. That is to say, 0 equals to 16x plus x square minus 36. And then you could factor this and find your solution, right? So you could do that. But I think the better approach here is to see what could be the possible values from the given choices. 36 is product of 2 and 18, and if I substitute 2 here for x, I do get 2, and 16 plus 2 is 18, right? So that becomes 2, this is 18, and that gives me the solution as 2. Perfect. So I will do it in this fashion. Perfect. Let's move on and check the next question. The radius OD of length 10 centimeters, so O to D is 10 centimeters, intersects the chord AB at P. Find the length PD in centimeters. So basically, we need to find this length. And we know it will bisect. Since this is the radius, that's the chord, P is the midpoint of AB, correct? Find the length PD in centimeters if the chord length is 16 centimeters. So we are given that A to B is 16 centimeters. That means AP is going to be half of 16, which is 8 centimeters, correct? So we have 8 centimeters here. We are also given that the radius is 10 centimeters, right? So we could say that the radius is 10 centimeters. So this length is given to us as 10. The radius O to D is also 10. So OA will also be 10. Correct? So O to D is 10. We need to find what is P to D. So we can find what is O to P and then get the answer. So that is a shortcut, right? So from here, we know OP square should be equal to OA square minus AP square, right? Which is OA square is 10 square minus 8 square, correct? So we get 100 minus 64, which is 36, is OP square. So we know that OP is square root of 36, which we have to take positive value, 6. So this is 6 units. Since OP is 6, DP, which we need to find, or PD, which we need to find, should be how much? So we know P to D should be equal to 10 minus 6, which is 4. So the answer is C. Well, this is one of the methods, right? So this, I'll say, is our method 1. Right? Now, we could also do this in an alternate way, using the intersection of chords also. So if you look at it, we can extend this. So that becomes a chord. Do you see that? So this, let's say this point for us is Q. In that case, let's look into the alternate method. So in that case, the product of this A to P and P to B should be equal to dP times PQ, correct? dP times PQ. Now we know this is 10. Let us say P to D is X, correct? So in that case, PO is going to be 10 minus X, right? So alternate method will be 8 times 8 should be equal to X times this length, which is 10 plus rather I should say 20 minus X, right? So we can write this as 10 plus 10 minus X. Is that okay? Or 20 minus X. So that should give you the value of X. This is an alternate method, correct? So we could get this as 64 equals to 20x minus x square. So that becomes a quadratic equation which can be solved to get the value of x, right? So that's an alternate method. However, you could straight away find with the concept of Pythagorean theorem, the solution of this. So I hope that makes sense, right? Let's move on and take the next question. Here, a rainbow is a complete circle. However, we only see an arc above the Earth's horizon. What is the radius of the circle containing the arc of the rainbow shown below? So this is the rainbow shown to you, right? So that's the rainbow shown to you. It is seen as a part of a circle, which is an arc. The distance here is shown as 0.8, and the chord length can be considered as 6. You get the idea, right? So the diagram here could be looked as like this, like in the previous question which we have done. So this is a smaller version of the same thing. So we're talking about this particular arc here, right? We're saying that this length here is 6 units, and from the center we need to find the radius. However, we are given that this is 0.8, right? So let me label this as A to B, which is 6 kilometers. So it is 3 each, 3 here and 3 here, correct? And this length is given to us as 0.8. We need to find the radius of the circle, that is to say, we need to find from center O what is this distance. Got it? So that is what we need to calculate in this particular situation. Okay. So now, in this case, we can again think about the chord segments theorem. So there are two chords, perfect. Now they are intersecting, and therefore, let us say that this from here to there, let me call this point as P. Okay. Let's call this as C and this as D. Correct? So in that case, we see that the diameter is 2r, right? 2r. So this length here to here is 2r minus 0.8. Therefore, what we have here is 3 times 3, which is 3 square, should be equal to 0.8 times this length, which is 2r minus 0.8, right? So 2r minus 0.8. Correct? This we have used the segments of chords theorem. Correct? So that is how we could actually find this. Now we can use calculator to calculate. So we have 9 divided by 0.8 is equals to 2r minus 0.8. So 9 divided by 0.8 plus 0.8 is equals to the diameter, or twice radius. So let's calculate this. So we have 9 divided by 0.8 equals to, we're adding 0.8 to it, right? So we get 241 divided by 20, which is approximately equal to 12.05. Right, so 12.05 is twice the radius. Now, so we need to, what is the radius? I think the answer is given here is the diameter. What is the, let me change this. What is the radius? What is the radius of the radius of the, what is the diameter? So I'm just changing the question to diameter. So 2r is 12. So the option, which is the diameter, so we get 12.05 as the diameter. So option C becomes the right option, right? So there's a typing error here. What is the diameter of the circle containing the arc of the rainbow shown below, right? That becomes the question. So the diameter will be twice the radius, which is going to be 12.05. Okay, so that's one way of doing it. Well, you could also do the alternate method, which is, we know this is r, right? And this length will be r minus 0.8, and this is 3. So we know 3 square, we could write this equation and solve, which is 3 square plus r minus 0.8 whole square is equal to r square. So when you solve this equation, you will get radius, which will be around 6 kilometers, correct? So, and then twice the radius will be your diameter. So that is how you could do it. So that becomes your alternate method. Using the segments of the chord theorem. So I hope that helps. So that is how you could answer it. Now here is the last question, which is extremely important question. Two mutually perpendicular chords AB and CD intersect at P. So they are perpendicular chords. Such that AP is 2 centimeters, P to B is 6 centimeters, D to P is 4 centimeters. Find the radius of the circle, right? So somewhere here in the center we'll be having O, and you need to find the radius of this circle. That means from O to P, let us say, right? Let's say that is the distance which you need to find. You can always pause the video, answer the question, and then look into my suggestions. Now here we'll use the segments of the chord theorem first, right? To find the length CP, right? So CP times 4, which is PD, should be equal to AP times P to B, right? So CP times 4, let me write times 4, equals 2. 2 times 6. So CP is equal to 2 divided by 4 times 6, which is 3. So we know CP is 3. Now to get the center, what we can do is, center will be midpoints, correct? So let me draw the bisectors of the two chords, right? So we'll do bisectors of the chords. So one like this, correct? The other one will be kind of like this, and let's say that is the center O for us. Now, since the total length is 8, so this will be half of 8, which is 4, correct? And here the total length is 4 plus 3 is 7. So we know CD is 7. So that means O2, let's call this point M as the midpoint. So O to M will be equal to, half of 7 is 3.5, right? So it is 3.5 minus 3, or let's say half, correct? So, and we get this point M to B as half of 8, 6 plus 2, which is 4, correct? So from here we get O to M as 0.5 or half, and now we can find what R is. So R square is basically equal to 4 square plus half square, which is 16 plus 1 over 4, which is 4 times 6, 24, 4 to 64 plus 1, or 65 by 4. So R will give you the value as square root of 65 divided by square root of 4, which is 2. So we get the answer as half of square root 65, which is option B. So that is how you're going to answer this question. In one of our videos, we have also derived a formula which could be used here. So we can say 4 times R square is equal to sum of squares of all these 4 chord segments, which is 2 square plus 3 square plus 4 square, 2 square, 3 square, 4 square, and 6 square. So that will directly give you the answer for R. right? So you could use this method also to find the answer, correct? So that is a method. I'll provide you with a link, rather I'll provide an extension to this video so that you can see how we can use this formula to find the radius of a circle when we have perpendicular chords. I would like you to pause the video, copy the questions, answer, and then look into my solution. I will actually provide you with complete concept to solve questions similar to what you see here. So let's begin with the very first interesting question from Mr. Thiru. Two mutually perpendicular chords A, B and C, D intersect at P such that AP equals to 4 centimeters, PB equals to 6 centimeters and CP equals to 3 centimeters. Find the radius of the circle. 4 choices are given to you. Now to help you answer, let me sketch, at least provide you with a diagram. So let us say this is the circle we are talking about, and we have two chords which are intersecting. To make it simpler, we'll take perpendicular chords as vertical and horizontal. Okay, so let's say one of the chords is as shown and the other one is kind of like this. So these are the two chords. Now let's say that this is the chord A to B and this is C to D, and they're intersecting at P. What we are also given here is that A to P is 4 centimeters, okay, and P to B is 6 centimeters. So just to, let me make this as A and this as B. Okay, so A to P is 4 centimeters, this is 4 centimeters. P to B is 6 centimeters. And we have CP as 3 centimeters. We are also given that they intersect at right angles. Now you need to find the radius of the circle. So let us say somewhere here we have the center, and you need to find this radius, right? So let me call this center as O and the radius as R. One of these is the correct answer. You can now pause the video, answer this particular question. Now to answer this question, we need to understand many concepts actually. It is not a straightforward question. So first thing we want to know is what is this length, right? Once we know this length, then there is a formula with which we can find what R is. So now these are called the segments of the chord, and these lengths are actually related. So what I will do here is that we'll actually derive related formulas and then solve this question, okay? Now some of you who know all these formulas can actually get the answer and then check the answer at the end of this video, right? So let's look into the relations which are important to understand. So first one is called the segments of the chord theorem. So let's see what this segments of the chord theorem is. Again, I'll just draw a rough circle. And segments of the chord theorem is a general theorem. It is applicable to any chords, right? So if I have two chords here, let's say these are the two chords, and let's say this chord segment is A1, A2. So this is one chord. The other chord shown in blue, let's say the chord segments are B1 and B2. Then according to this theorem, A1 times A2, the product of these two lengths is equal to the product of other two lengths, B1, B2. Right. So for any two chords, this is for any general formula, right? Any chord segments. Now this is a very important theorem which most of the students will know, right? So in my videos, why it's globally watched, so many students may not know this theorem. That's why I'm taking my time to also prove it. Now the proof is not very difficult. Actually, you can just join these points. So you form two triangles, correct? Now in these two triangles, you can see that we have same angles. These are vertically opposite angles. They are same, correct? Also, what we see that these two angles will also be same. Right? Now these two angles are same because they subtend to same arc, right? So you see this arc. So this arc is common to both these angles, so they are also same, correct? Let's name them. Let's say we use them like, let's say A, B, C, D as we did earlier. Let's call this point as P, okay? Now what we see here is that the triangle APC is similar to triangle DPB. Reason being that the angle APC is equal to angle DPB. This is first thing. This is a vertically opposite angle, right? And angle CAP is similar, I should say equal to PDB. Let me write like this. Because they subtend arc CB, right? Same arc. So that is why they are both same. So they are similar triangles because of AA properties, correct? So of course, when two angles are similar, the third one is also going to be exactly same, correct? So let me use another ink here to show that third one is also sum is. Now these two angles are given across this arc, correct? That's the reason. Okay, now using the similar triangle properties, AP, which is, let me write, AP over PC should be equal to what? Now AP is opposite to this angle, therefore opposite to this angle is P to D. So we'll write P to D. And P to C is opposite to that angle, and opposite to that angle is P to B, right? So we get P to B. Does make sense? So you have to look for similar triangles, which two sides. Now if you cross multiply, we get AP, let's say AP times PB, cross multiply, right, equals to PC or CP, we can say PC or CP, right? Let me write this as CP times PD. Does make sense to you, right? So now AP times PB, which is same as A1, A2, right? So this is our segment A1, this is segment A2, right? Equals to B1, B2. Is that clear to you? So that is how we can actually prove it. Okay. So first proof, very important, which we say is a chord segments of chord theorem, which says if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. That is, A1 times A2 is same as B1 times B2. Perfect. Now let's also look into radius relation with intersecting perpendicular chords. Okay, so let me this time sketch the circle on this side. A slightly bigger circle. I need to write a lot of things here. Okay. So we'll have a very similar diagram as we did earlier. So we have two chords. One will take horizontal, the other one vertical and horizontal. Okay. And let us say that these sides are A1, A2, right? So these are your chord segments. This is B1 and this is B2. So these are your two chords. Now the important thing to understand is that where is the center? Well, center of this circle will be at right bisectors. So basically, right bisectors of chords intersect at center. Right, so basically, if I have a right bisector here, let's say this is my right bisector, and for this one, let's say this is the right bisector, then wherever they intersect, that becomes the center of the circle O. Is that clear to you? Okay. Now, we need to basically relate the radius to the chord segments, right? Because we know the chord segments in our example. Okay, now, what we should do is we should find what is this length, right? We need to find basically this length. Okay, so what we know here is that this length here is half of this total, right? So this length is A1 plus A2 divided by 2, right? Because this is the center, perpendicular bisector. So that line is a perpendicular bisector. So it bisects this chord into two equal parts whose length is A1 plus A2, right? Clear? Okay. Similarly, this length here is basically B1 plus B2 divided by 2, since we have the right bisectors, right? Okay. Now, we need this length shown here, that much. How much is this? This is what we need to figure out. Well, clearly, this is also A1 plus A2 divided by 2. Take away this portion. Perfect. Now, what we can do here is to find this particular length, which is A2 minus all this. Correct? So, or we can also say like this. This is also A1 plus A2, right? So, the length which we are interested, let me label this. Okay. We were saying that this is A for us, this is B for us, C. So I'm trying to label this as we had in the original question. Let's call this point as P. Okay. Now in this case, this is midpoint. Let me call that midpoint as M. So what is PM equals to? Length PM will be half minus A1, right? So it will be A1 plus A2 divided by 2 minus A1. Clear? So we could now say this is A1 plus A2 minus 2 times A1 over 2, which is basically equal to A1 minus A2 minus A1, A2 minus A1 divided by 2. Clear? So this length is A2 minus A1 divided by PM. Okay. So we get this length also, which is, okay, let me write here itself. A2 minus A1 divided by 2. Clear? Okay. Now, we have a right triangle, as you can see. We have a right triangle. So in the right triangle, hypotenuse, which is the radius for us, which is O to B. So radius R square will be equal to B to this, which is B1 plus B2 divided by 2 whole square, plus this length, which is PM for us, A2 minus A1 divided by 2 whole square. Clear? Correct. Now let's expand and simplify. So what we get here is b1 square plus 2b1 b2 plus b2 square, and in this case we get a2 square plus minus, this is minus a1 a2 plus a1 square, correct, divided by 4. So we can write 4 as 1 over 4 here. Clear? Okay. Now let me rearrange this. Write this as 1 over 4 times a1 square plus a2 square plus b1 square plus b2 square plus, we have 2b1 b2 minus 2 a1 a2. Clear? Now from the chord segment theorem earlier, we know, earlier we did chord segment theorem, right? From there we know the relation that a1 a2 is equals to b1 b2. Is it okay? So 2 times a1 a2, they are equal, so this is equal to 0, clearly. So if you multiply by 2, then also they are equal. So this part is 0. So what we get here is we can just cross multiply. We can say 4r square equals to a1 square plus a2 square plus b1 square plus b2 square. Is that clear? Since that is 0, right? So this is the formula which relates the chord lengths with the radius. So that is how we can actually find the radius. Is that clear to you? Correct? So now we know each chord length, which is a1, a2, b1, b2, their squares, when you add them up, will be 4 times radius square. Now that is the formula which was required, and I hope the derivation is perfectly fine. Correct? Now let's really solve our question. Clear? So basically we derived 2 formulas. One was the relating chord segments a1 a2 equals to b1 b2, correct? Second, we said 4 times r square is equal to a1 square plus a2 square plus b1 square plus b2 square. So you have to remember these formulas to solve any multiple choice questions based on this concept, right? Then it is very fast to do. Now let's look into this. So we basically need to find what PD is. So what we know from here is CP times PD should be equal to AP times PB, correct? So from here CP is 3, so 3 times PD is equal to 4 times 6. So we know this length PD is basically equal to 4 times 6 or divided by 3, which is 8, right? Very simple. So we got one length, which is this length as 8. So we have all these lengths, right? Now we will substitute in the second formula. So this was using the first one. Now using the second one, 4r square, we said 4r square is equal to 3 square plus 8 square plus 4 square plus 6 square. Clear? So we can just add them up. So we get 9 plus 64 plus 16 plus 36 is 4r square. Clear? Now normally you can do it without calculator, but let's do it with calculator now. So we get 9 plus 64 plus 16 plus 36 equals to 125. 125. Okay? So we get r square is basically equal to 125 divided by 4 square root. Within square root, we have 125 divided by 4, which is in decimals 31.25, right? So r basically is 31.25 square root. Clear? So the first one is the right option. So that is how you're going to do. You don't really have to use the calculator for these calculations, but that is how it could be solved. So let me summarize the solution. So in any circle, if you have two perpendicular chords, then their chord segments product is constant, right? So that gives you the missing chord segment length. Then the other formula which we just derived is 4 times r square is sum of squares of each chord segment. That gives you the straightforward answer, so it should not take more than a minute to answer now similar questions. Perfect. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching, and once again, thanks to our subscriber for posting such brilliant question. All the best.